Okay. Hai, Assalamualaikum dan selamat malam semua. Okay, continue our discussion on section B and section C tonight. Okay, you can refer to the model test paper. Okay, let's look at section B. Section B, 20 marks. There are 2 questions, you just need to answer 1. Okay, jawab 1 saja. 20 marks. Let's look at number 9. Okay, diagram 9.1 shows a candle flame placed between 2 metal plates P and Q. PQ. The metal plates are connected to EHT supply, which produces a strong electric field between P and Q. Okay, is positive, negative. Is this one is positive? This one should be negative. Okay, so means this one will be positive. This one will be negative. Okay, means there will be electrical potential energy across the 2 plates. Means there will be electric field between the 2 plates. Okay. Okay, A1. What is the meaning of electric field? Okay. Okay, you need to answer the question on the paper provided. Okay, there's a space provided for you all to answer. So for this discussion, I will just write below here. Okay, just so that easy for you all to refer to the question and the answer at the same time. Okay. A1, what is the meaning of electric field? Okay, definition, you need to write it completely. So electric field is the region, region, kawasan, region where a charged particle or a charged object, a charged particle experience electric force. Okay. Example, we have charge unit positive. Okay. Around the charged particle positive, there is electric field. Okay. Like this. Out from positive. This is the electric field for this charge positive. Means if you put another charge particle here, let's say negative charge unit, means we put in the electric field of this charge object or charge particle positive or charge unit, this one will be attracted to it. Means there is electric force act on it. If you put further away, you put here, nothing happen because it outside the region of electric field. So that is a definition for electric field. It's the region where charged particles experience electric force. Okay. A2. Should be A2 here. What happens to candle flame when the switch is on? Normally there is a knowledge question, 4 marks. Okay. So whenever you answer the question, make sure you check the marks provided. If 1 mark means 1 point enough already. If 4 marks means at least there are 4 points for you all to explain or to answer the question. Okay. What happens to the candle flame when the switch is on? I will shift to the next space so that here, because the space is too small. Okay. Candle flame when the switch is on. Okay. So what happens to the candle flame? Okay, this is the question just now. A2. A2. Okay, 4 marks. Means minimum I must have 4 sentences or 4 points in my answer. Okay, first, when you light up the flame itself, what happens to the molecules of the air around it? Okay, what happens is the heat from the candle flame, okay, ionizes air molecule. Ionizes means produce positive and negative charge. Okay, it means there is a positive and negative ion produced. Okay. When the EHT power supply is on, EHT is on, candle flame will be dispersed into two directions. Dia akan bergerak kepada dua bahagian, terbahagi kepada dua bahagian, disperse ataupun kita panggil tersebar kepada dua bahagian. Contohnya macam ni, kalau ini adalah negatif, ini adalah positif. Okay, so this is the candle flame. This candle, the flame will be spread like this. Okay, so you can see the positive ion, negative ion, same number. Let's say here got 3, here also got 3, means showing they have same number of ions here. So you see the negative will be attracted to negative plate. Okay, the negative ions attracted to positive plate. But this is not symmetry, not symmetry. Larger portion attracted to negative, smaller portion attracted to positive. Okay. Okay, the positive ions attracted to negative plate and negative ions attracted to positive plate. Okay, we have Emily here 1 point. Yeah. Okay. Now we want to explain what exactly happened. The portion of flame is the larger portion. Sorry, I will again. Okay, larger portion of flame is attracted to negative plate because positive ion has greater mass than the negative ion. Okay. So this is how you write. So that you have 4 points in order to get 4 marks. Okay. First, let's look at the answer from here. Okay, so means ionize here to show that there is a charge object or charged particle which is positive ion, negative ion. Okay, so candle flame disperse to two direction. You explain positive and negative plate attracted to positive and negative plate. Larger portion attracted to negative. Why? Because positive ion have greater mass. Okay, so means to get 4 marks. Okay, you must state all the points required. Okay, so this one is for the question for A2. Explain knowledge punya soalan. Knowledge punya soalan lah 4 markah. Yeah, Tevesh Kumar. Correct. Okay. Good. Okay. Okay. Okay, let's go to the next question. Part B. Yeah. Diagram 9.2 shows an electric circuit. Okay, there are two resistor here, 5 ohm and 12 ohm. There are two switches, S1 and S2. Okay, power supply here. Mentioned here is 2 volt, and then there's a small value of current, a small value of resistance, 1 ohm. So what can you say about this one? What topic exactly this one? If mentioned battery has resistance, means internal resistance, correct or not? And then also you go through the whole question first. EMF of the cell is 2 volt and its internal resistance is 1 ohm. Okay. Calculate the reading of ammeter when only S1 is on. Part 2. Both switches S1 and S2 are on. Okay, normally for section B, there is a one calculation part, 5 marks, 5 marks. Okay, let's look at here. So this one is EMF. This one is internal resistance. Then we have here R1 and R2. Okay, let's say for the first part, S1 is on. Okay, S1 is on. So means we have just have this part only. Okay, so we need to calculate for reading of ammeter, means current. We need to find current. Okay, for topic electromotive force, you are introduced to this formula. EMF equals to V plus I small r. EMF equals to potential difference plus current multiply internal resistance. Okay, sorry for 1 minute break. Okay, electromotive force means the total voltage supplied by the battery. Some will be used to overcome external resistance, which is V, and some will be used to overcome internal resistance. Okay, so the work done to overcome the external resistance actually equals to the voltmeter reading. If we put voltmeter across the battery when the switch is on, okay, should be the same. Reading of the voltmeter across the battery and reading of voltmeter across R1 should be the same, okay, when the switch is on. Okay, so we can say from here, V, if only S1 is on, S1 on, S1 on, so V actually equals to IR1. Okay, so electromotive force equals to IR1 plus I small r. Thus, EMF equals to I R1 plus small r. Okay, can you get that this one? This equation. Okay, because no mention about value of V. In this case, we want to find I. Just given R1, R, and EMF. So I will use this formula. Okay, so EMF equals to I R plus small r, R1. EMF is 2 volt, current I. R1 is 5 ohm plus small r, 1. Okay, meaning I equals to 2 divided by 6, we get 0.33 ampere. Okay, don't leave your answer in fraction. Final answer at least 2 decimal. Okay, so this is the reading of the voltmeter when S1 is on. Okay, let's look at next questions. Okay, both switches S1 and S2 on. Okay, both switches on. I have this one on. Now we have two resistors in parallel, R1 and R2. Thus, for the external circuit, you must calculate for effective resistance. Okay, effective resistance, remember the formula for parallel resistor. Okay, parallel one, if I want to calculate for the parallel part, I just put like this. Okay, is equals to 1 over R1 plus 1 over R2. Okay, which is equals to 1 over 5 plus 1 over 12. Okay. Okay, try to solve it. I make it 60, 12 plus. Okay, so 60 over 17. Okay. Okay, 3.53 ohm. So I get the effective resistance when S1 and S2 on. Okay, now I want to calculate for reading of the voltmeter, means I will use the same formula. Okay, now E equals to I R parallel, effective resistance plus R. Okay, actually the same method. Total EMF still 2 equals to I 3.53 plus 1. Okay, so you calculate for this one, you should get I equals to 0.44 ampere. Okay, you can see when you add one more resistor in parallel, effective resistance of the circuit decrease, current increase. Okay, so I equals 0.44 ampere. Okay, okay, can you get now this one? Yeah, yeah, good. Devesh, you try. Okay, good try. Okay, now we go to the next one. Part C. Yeah? The diagram 9.3 shows 3-pin plug connected to electric iron level 240 volt, 1000 watt. A fuse is installed in the 3-pin plug. This is fuse. Table 9 shows characteristic of metals used as fuse wire. So the main point here is fuse wire, metal for fuse wire. Okay, look at the table given. Okay, this one is the characteristic of the metal. We have four metal here, P, Q, R, S. Okay, based on the table above, explain suitable characteristic of metal that can be used as a fuse wire. Decide which metal is the most suitable metal to be used as fuse wire and give reasons for your choice. Why we have a fuse wire here? This is a safety for the iron, to the iron, means to prevent current leakage, current leak. Okay, suddenly there's a high current flow that will spoil the iron. So the fuse will melt first. So means if you want the fuse to function normally, means just melt at a certain value of current only. So what are the characteristics of the metal that we need to discuss? Okay, that we need to fix for the metal. Okay, let's look at the first one. The first one is melting point. Okay, we choose between high and low. Actually, it's not too high, not too low. Cannot be too low. If it's too low, easily melt. If high temperature, it easily melt. So we don't want it to be too low. So I've just consider higher instead of low. So I will just take higher. I will remove the low one. Okay, the value of ampere, how to know? We can just calculate from here. Because the label given 240, this is the power rating, 240 volt, 1000 watt. So actually this one is voltage, this is power. So let's try to calculate the current. I equals to P divided by V. So it's 1000 divided by 240. I get the value is 4.17 ampere. So means the current can flow to the iron is 4.17 ampere. Okay. So the fuse here must have a current or label for the fuse current must be slightly higher than this. It cannot be lower than this, cannot be lower than this. Must be slightly higher. Okay, because current leak normally is more than the normal current. This is a normal current because we calculate based on the power rating. Okay, so I will accept, okay, which one is slightly higher. Okay, maybe I just remove this one. Okay, yeah, the rest I just try to accept it. 4.2 also is not so good because here is 4.17, just a little bit. Okay, but we go through the next one. Okay, diameter of wire. Okay, diameter of wire, we don't want it to cause energy loss, so we use a lower resistant material. Lower resistant material means bigger diameter. I will reject the small one, bigger diameter. Okay, we look at resistivity, also same. We take the lower one. Okay, normally the lower one, if resistivity, the melting point also is quite moderate, not too high, not too low. Okay, Q, resistivity, this one high, I just reject it. Okay, now let's look at the, which one I should use, which one is better. Okay, now I have a between P and S. Because here got 4 tick, here also got 4 ticks. Now, we can just look at again the value of ampere here. Normally fuse, we don't have this level 4.2. Fuse, we have like 5, 10, 13 or something like that. Okay, so I just reject this one. So means I will accept S. Okay, I will accept S, which is more suitable compared to P. Okay, now I choose S. After I choose the best one, then only I start to answer. Okay, based on the characteristic here, melting point, ampere value, diameter of wire, and resistivity. Okay, so I will write here. Okay, I will have 3 columns here for this part. Okay, the first one, characteristic, is melting point. Okay, melting point. Okay, so suitability is higher. I just write that first. I write out all the characteristic first. Okay, the melting point, then we have ampere value. Ampere. Okay, 3 diameter of wire. Or resistivity of wire. Okay, you can write using this 3 column, or you want 2 column also can, up to you. Ampere value must be slightly higher than the current flowing through the iron. Okay, okay. Higher than 4.17 ampere. Okay, higher than 4.17 ampere. Diameter of wire must be larger. Resistivity must be lower. Okay, now we want to write the reason. Okay, high melting point means withstand high temperature. Because normally iron they use for quite a longer period, maybe 1 or 2 hours at the same time. Okay, so this one, make sure melting point higher so that it does not melt due to higher temperature, but we need it to melt due to higher current or leakage of current. Ampere value must be higher than 4.17. Okay, so that the fuse does not melt at normal current 4.17 ampere. Okay. Okay. Diameter larger so that resistance is lower. Lower resistivity also, you can use the same reasoning for this one. Resistance also is lower. Okay, so from here, what is your choice? Okay, there are 4 points only, 4 characteristics, and the suitable characteristic that you choose, you write the reason can be repeated, okay, and then you can choose the best one. Okay, so S is chosen because it has higher melting point. Just copy back at the left side here. Okay. Ampere value 5 ampere. Larger diameter and low resistivity. Okay, so you have all the points. So you have how you get points from here. Okay, this is one pair. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you have 10 marks for this one. Okay. Okay, if you have questions, you can write in the chat. Okay, that one is for the essay part 10 marks, number 9. So for section B, actually, it's quite easy for you all to score. Make sure you choose the best one first, and then you just answer based on the best one. Don't mention the value. For example, ampere value is 4.2 ampere. So don't state the value, just use the word, because when they give you PQRS, actually you need to compare. So actually you need to compare between them, which one is the best one. That's why we use the word compare word here. Nampak? Compare word. So bila compare word, jangan mention value. Walaupun dalam table era value, jangan mention value. Hanya guna compare word. Is higher, lower, bigger, smaller. Okay? Itu saja. Itu tujuan dia, sebab dia bagi 4, you kena buat compare. You kena buat comparison between the 4 metal. Okay? That one is for question number 9. Okay, now we look at number 10. Okay, number 10, diagram 10.1 shows a driver is traveling in a car on a hot and sunny day, can see a pool of water appearing on the road due to total internal reflection. They give you the concept already. Angle of incidence greater than critical angle. So many information given. Okay. What you observe here, actually, we call it the phenomenon of mirage. Okay, mirage. It's optic illusion. When you reach that point, there's nothing there. Okay, from far you can see like pool of water, but when you reach that spot, there's nothing there because this one is only optic illusion. Okay. Okay. What is meant by critical angle? Okay, when come to the topic of total internal reflection, you must understand the meaning of critical angle. Okay. Let's say this is a glass block, this is center, this is angle, this is a incident light, normal line, this one is the angle I. Okay, so travel from glass to air. Okay, travel from glass to air, light ray will be bent away from normal, meaning the angle will be larger. Angle will be larger than I. Let's say at certain angle I here, suddenly it travel exactly at the boundary. Means angle of incident R here is 90 degrees. If this angle I produce angle of refraction 90 degrees, thus this angle I, we call it critical angle, C. Okay, critical angle. Okay, if more than critical angle, what happened? This one at the borderline already, air glass at the borderline, boundary. If suddenly you increase angle larger than I, of course, angle R will be greater, correct or not? Of course, it will move here. Something like this. Let's say I increase the angle to here, larger I. Of course, angle R will be greater than 90. If greater than 90 means it will go down here. Okay? So when go down here, we don't call it refraction anymore because it travel from where? Glass back to glass. So this one, we call it total internal reflection. Okay? Itu maksud dia. So critical angle tu maksudnya border-border. Dekat borderline. Maksudnya sikit lagi je dah nak masuk dalam glass. Okay? Jadi angle, critical angle is angle of incidence that produce angle of refraction 90 degrees. Okay? An angle of incidence that produced angle of refraction 90 degrees. Okay? Okay, we call it critical angle. Okay, critical angle. Okay, explain how pool of water appearing on the road. 4 marks, knowledge punya soalan, 4 markah. Okay, so you need to explain using the concept. Actually, the point is already mentioned here. This question very sangat bagus. Dia dah bagi point dekat you all. So ada point di sini, total internal reflection, angle of incidence is greater than critical angle. Okay, dah ada kat situ. Okay, we try to answer this question. So I will shift to the larger space to answer this one, to explain how the pool of water appearing on the road means mirage. Okay, mirage. Question number 10, number 10 part A, A2. Okay, actually this type of question sometimes you can use diagram to explain. Aid of diagram, okay, to explain this type of questions. So we try to answer. Okay, the first point. Okay, this is 4 marks. So I will include concept of total internal reflection and critical angle. Okay, if I just sketch roughly just to show to you all. Okay, during hot day, so this is the road. This is you inside the car. Okay, very hot day. Okay, so during hot day, as you know that air and gas, and also this one is solid, the road. So normally the road is hotter than the air above. Okay, hot. The ground is hot during daytime. Okay, so means the air layer near to the ground is hotter than the above one. So means we can just divide the air into a few layers of air with different density according to its temperature. Okay, because temperature different means density also different for air. Okay, so this one is hot, hotter. This one is hot. This one is cold, let's say. Okay, I just want to show you the difference. Okay, so let's say light coming from the sun or maybe coming from the cloud from above there. Okay, travel from cold to hot, meaning denser to less dense. Denser to less dense, it will refracted away from normal. Okay, from here, refracted away from normal. Okay, so reach here. So you can see this, the first angle I here. So this one is cold, this one is hot. Again, means denser to less dense. Okay, denser to less dense. So it's quite hard for me if I draw the car here. So I just want to draw your eye, so easier. Okay, okay. So this one refract lagi. Okay, refract lagi. Away lagi besar. Okay, means the angle is greater. Suddenly it become equals to the critical angle of air for this part. Okay, so this one means it will be at the boundary. But if suddenly the angle here, I, is more than C, what happened to the light ray? It will be reflected. It will be reflected, total internal reflection. Okay, let's say if your eyes is here, observer's eye, okay, your line of vision is always straight line. So what you observe is not this one, the image, the real object, but you will observe image of the object formed on the road here. Okay, so why it looks like pool of water? Because the light ray coming from the moving object above here, like clouds, is moving. So when it moving, it shows like effect of water, pool of water. Okay, so this is the mirage. Okay, this is by drawing, but if you want to draw to explain, you need to label it completely everything. Okay, so if you don't want to draw, also can just explain. Okay, just during hot day ataupun hari yang panas, hari yang panas, layer of air near the road is hotter. Is hotter than the above layer of air. Okay. Or we can say layer of air above is denser than the layer of air below, closer to the root. Okay. light ray from the sky travels from denser to less dense medium. Causes it to refract. Okay. The decrease in density of air layer causes angle of incidence to become larger than the critical angle. Total internal reflection occur reflected rays gets into the observer's eye. Observer observe image on the road. Okay, so it's quite long. Maybe you can make it simple words. Okay, so the point is here. What we want to explain here is that the difference in density of layers of air, the point here. Okay, layers of air above and below, different density. And then light travel from denser to less dense. Okay, refraction occur. Okay, angle of incidence larger than critical angle. Total internal reflection occur. Okay, observer observe the image on the road. Okay, so you have 4 points. Means you include all the concept related. Konsep dia apa? Hanyalah nampak di sini ya, refraction, and then angle incident larger than critical angle, and then total internal reflection. Okay. Hi, and Bu Mani. Yeah. Okay. Make it a simple words. Easy sentence saja. No need to have a very long essay to explain this one because 4 marks only. Mirage. Okay, part B, an engineer chose a glass refractive index n equals 1.6 as a core for optical fiber that he want to produce. Calculate critical angle of the glass. Okay, you can check the list of formula if there is any formula that can be used. Okay, given is refractive index. So we have one formula related that relates between the refractive index and critical angle. N equals 1 over sine C. So you just use this formula to calculate. Okay, N equals 1 over sine C. So you have n is 1.6 over 1 sine c. So you have sine c equals to find the value. Yeah. Okay, you will get the value of c, c. Okay, you will get critical angle. C equals 38.68 degrees. Okay. Okay, part 2. Diagram 10.2 shows a path of light travel in simple optical fiber. Copy and complete the path of light ray in the diagram until it come out from the optical fiber. 3 marks. Drawing, drawing. So actually for the optical fiber, it consists of 2 layers actually. Outer layer and inner core, we call it. Outer layer and inner core. Okay, mesti ada 2 layer ya. Layer. Okay. Okay, so we have something like this. Okay, this part. Okay, is the outer layer. And inside here, we call it inner core. Atau inner layer also can lah. Okay, different density between these 2 layers. As we know that for total internal reflection to occur, there are 2 conditions. The first one is angle I must be greater than critical angle. Number 2, light travel from denser to less dense. Okay, so it means inner core is denser, outer layer is less dense. Okay, that one is the optical fiber. Mesti 2 layer. Kalau you lukis pun dalam dia minta you lukis, you mesti lukis 2 layer. Okay, so this is the incident light. Okay, gets into the optical fiber. Okay, and hit this point. At this point, draw normal line. Normal line is 90 degrees to the surface. You look at the angle here, 60. Angle I equals to 60. But you just calculate before, just now, is 38.68. 38.68 degrees saja. Means the angle I here is more than C. More than C, and the light travel from denser to less dense. Okay, now it's already fulfilled. These 2 conditions, total internal reflection will occur. Means this one will be reflected. Okay, so dia akan reflect. Okay. Okay. Let's say angle here also is greater. Then again, it will go here. Continue. Okay, draw normal line. Okay, it will go here. Draw normal line. Then it will go here. Let's say it come out from here. Okay. Okay, this is the diagram that you should draw until it come out from the optical fiber. Okay, so how to get 3 marks for this one? First one is showing total internal reflection. So you can see the total internal reflection occur. Okay, And then you draw at least, okay, more than two total internal reflection. Okay, ada 1, 2, 3 lebih kan. Okay. Dia dapat satu lagi markah. Okay, and then you show come out from here. Okay, so 3 markah. Labelkan arrow to show how the light is travelling, starting from P here and they come out from here. Okay, so this is a complete diagram. Okay, for the optical fiber. Optical fiber now is greatly used in telecommunication, Wi-Fi, using the optical fiber. It's very, very good because you can see even the light ray that transmit from here, it will come out, we can say 100% without absorbed by the surface of the optical fiber. It's completely reflected. Compared to a mirror. Mirror also apply reflection, but mirror will absorb some of the energy of light. So the light ray that reflect by mirror normally is blur. But if using optical fiber, we can say 99%, 100% it will be reflected. That's why it's greatly used even in medical for this optical fiber. Endoscope. Okay. Any question? If you have any question, you can just write there. Okay, next, part C. You are asked to investigate characteristic material to produce optical fiber. Okay, let's check the material here. Is also we have PQRS, characteristic critical angle, strength, flexibility, diameter of fiber. Okay, if we use this optical fiber as endoscope in the medical, okay, just to check what is inside your stomach, they just put in the endoscope with this fiber, okay, to check what is inside your stomach. So we can choose based on that application also, okay, or maybe telecommunication. Okay, the first one, of course, we want total internal reflection to occur. Optical fiber mesti berlaku total internal reflection, then only dia adalah satu yang effective, okay, component that can be used. Kita nak berlaku ini. So you must remember there are two conditions just now. Mesti apa? Angle of incident must be greater than critical angle. If we want the critical angle of incident to be greater than critical angle, means even at low critical angle or low angle of incident also, total internal reflection can occur. Means the critical angle cannot be high. You must have low critical angle. So I will just remove which one I think which is not suitable. So I just remove it. So now I just check here. Okay, maybe I remove the two which is higher. Okay, I just remove two higher. I just take these two. Okay, because I want to check more. Okay, strength must be high, of course. I'm not easily break, correct or not? So I don't want this low. Flexibility means easily to bend here and there. For example, it's put into endoscope to put into your stomach, and so that it can bend and pass through a small parts in your stomach easily. So it means flexibility should be high. Okay, I don't want low, should be high. Okay, diameter of optical fiber should be small. Okay, so it means it can just pass through a small hole easy. Like I remove the one which is thick, so I will accept all the thin one. Okay, now let's check which one is the winner with 4 ticks. Then I can see S got 4 ticks from here. Okay, so I will remove the rest. Okay, I will choose S, means I will explain based on S. So based on S, as comparison to PQR, the critical angle is smaller. The strength is higher. Flexibility is higher. Diameter of fiber is thinner. So means I just explained the characteristic of S only. Okay, now let's go to the table. Critical angle, strength, flexibility, diameter of fiber. Okay, this is for number 10, part C. Yeah? Okay, characteristic. The first one, critical angle. Characteristic, the first one, critical angle. Strength, number 2 ialah strength. Number 3 is flexibility. Okay, number 4 is diameter of fiber. Ataupun optical fiber. Okay, suitability, critical angle just now, smaller. Strength, higher. Flexibility, higher. Diameter of fiber, thinner. Okay, as I mentioned earlier, compare what? Because you are comparing between PQRS. Then you make your decision like this. Okay, reason for the first one. Okay, smaller critical angle means even at small angle of incidence, total internal reflection can occur. Okay, means total internal reflection can easily occur. Kalau you nak tambah lagi boleh. Can easily occur even at lower angle of incidence. Okay, you letak angle kecil pun dia dah total internal reflection. Itu bagus. Okay, strength. Okay, higher. So when we talk about strength ataupun dia punya tu mestilah strong. Okay, so not easily broken. Okay, not easily broken. Tidak mudah pecah. Okay, high flexibility. Easily bend. Okay, to reach hidden area, for example. Contohnya dalam perut you ada kawasan yang terlindung sikit, dia boleh bend dan masuk. So easily bend to reach hidden area. Diameter must be thinner, means can pass through narrow space. Okay, tempat yang sempit pun boleh masuk sebab dia kecil. Okay, so you have all this and then make your decision just now as is chosen. Because tulis balik je lah reasoning tu. Smaller critical angle. Okay. Stronger. Okay. Flexible. And smaller diameter ataupun thinner. Okay. Again, you will get 10 marks from here. No need to add extra characteristic. Just discuss what given in the table. One pair. Second pair. Third pair. As chosen, reason, 10 marks. Okay. So if you know how to, you know the concept, I think this one shouldn't be a problem for you all. Okay. Section B, you can score full marks normally. Okay, can score easily 20 marks. Okay, let's look at the next question. Okay, section C, the last question. Section C, this one only one question, so compulsory to answer this question. Number 11, diagram 11.1 shows heating graph for material X, material Y. X and Y have same mass, heated by identical heaters. Identical heaters means same power. Okay, so this topic is topic heat. Okay. Heating curve. So you can see P and Q. This is a material X, material Y. Graph P, graph Q. Okay, let's look at the first part. What is the meaning of specific heat capacity? Definition. Amount of heat required. Heat needed atau required to increase the temperature (1 kg substance by 1 degree Celsius. Okay, nampak tak specific. So 1 kg substance, temperature by 1 degree Celsius. Question B. Observe graph P and Q for solid state. Compare melting point X and Y. First point, melting point X and Y. Time to reach melting point. Gradient of the graph for solid state. Relate gradient and with specific heat capacity. Deduct relationship between specific heat capacity and rate of increase in temperature. Okay, 5 points. Bahagian B, compare. Okay, 11 B. First point, compare between melting point. Look at the graph again. For P, reach here you can see it reached a constant temperature 100. Means this is the melting point for P, for graph P, or for X. And then untuk ini 80. So melting point of X is higher than melting point of Y. Okay, first point, melting point of X is higher than that of X of Y. Okay, melting point of X is higher than Y. First point. Second point, compare between time taken to reach melting point. Time taken to reach melting point for P is 5 minutes, for Q 6 minutes. Okay, means for x shorter time taken. Okay, for x shorter time taken. X takes shorter time to reach melting point. Then y. Okay. Third one, compare between gradient of the graph. Okay, gradient. Gradient. Okay, you can see the steepness of the graph. Steepness of graph P is higher than Q. Means gradient of P is higher. Okay, gradient of graph P for x is higher than Q. Okay, gradient is higher. And then compare, relate between gradient and specific heat capacity. Look at again the graph. Tengok graph lagi sekali. Okay. Try to relate to the formula. Specific heat capacity equals to PT divided by M theta. Okay. Given just now, same mass. So mass constant. I will just cut. And I want to see the relationship. Identical power. And then C from here is depends on T and okay. Ataupun C equals to KT over theta. Okay, one step here. Let's say theta is increase in temperature. So gradient equals to gradient change in temperature divided by time. Theta over T. That one is gradient. Okay, so means from here, theta over T is equals to K over C. So gradient equals to K over C. Okay, means from here, higher gradient means smaller C, the relationship from here. Okay, higher gradient means smaller specific heat capacity. So this one you need to try to relate using formula. Okay, if not, you cannot get from the comparison just now. You need to look at again the relationship between specific heat capacity and gradient. Okay, so we get from here the higher the gradient, the smaller the the specific heat capacity. Okay. And then you need to deduce relationship between specific heat capacity and the rate of increase in temperature. Okay, we look at again just now. Rate, this one also known as rate of increase in temperature. Theta per second, which is equals to gradient. From here you can see gradient and specific heat capacity is inversely proportional. Okay, means you can write something like this. The smaller the specific heat capacity, the greater the rate of increase in temperature. Okay, so actually a rate of increase in temperature just now is, we already showed that this one actually is gradient. Okay, gradient. Okay, so actually from here to here, if you are able to relate gradient to rate of increase in temperature, you will get the last one. Okay, so 5 marks for this one. Okay, 1, 2, 3, 4, 5. Okay, make sure you do all the required marks. For this one, 5 points for 5 marks. Okay. Okay, you have any question? Boleh tanya kalau ada soalan. Okay, we go to the next one. Explain sea breeze phenomenon during the day. Ada soalan compare 5 markah, compare, relate, deduce 5 markah. And then soalan konsep juga 4 marks. Sea breeze. Okay, bahagian C ya. Okay, 4 marks. Sea breeze occur during daytime. Okay. During daytime. Land is hotter. Land with smaller specific heat capacity is hotter than the seawater. The air above the land is hotter and rises up. The cold air above the sea blow towards the land. To fill the empty space. Okay, the cold air blows from sea to land is sea breeze. Okay, so during daytime, land with smaller specific heat capacity is hotter than the seawater. The air above the land is hotter and rises up. The cold air above the sea blows towards the land to fill the empty space. The cold air blows from sea to land is known as sea breeze. Okay, nampak konsep lah. Jawab mesti ada konsep. Okay, nampak konsep yang saya guna di sini. Specific heat capacity, hotter, heats up faster than seawater. Air, okay, hotter, rises up. Cold air blows to the land. Okay, 4 marks. Okay, part D. Okay, if you want to read for longer time, for longer period for this part, you can pause the video. I will continue part D. Okay, diagram 11.2 shows design of car engine radiator, specification of the cooling liquid. Okay, you are required to give some suggestion to modify. Suggest modification. More effective can be used in winter, musim sejuk. Okay, aspect given. Number of fin blades, size of fan, specific heat capacity, boiling point, freezing point of the cooling liquid. Okay, so kita diberikan semua aspek. Okay, untuk ini kena tahu purpose dia winter. Used during winter. Okay, same thing. I will answer in this form, table. Part D, number 11. Aspect. The first one is number of fin blades. Tulis dulu semua aspek dia. Size of fan, specific heat capacity, of cooling liquid, boiling point of cooling liquid, and then freezing point of cooling liquid. Remember just now, effective use in winter, musim sejuk. Winter. Okay, so kita kena make sure dia tak freeze lah. Okay, kalau at lower temperature. Okay, suggestion. Number of fin blades must be large ataupun more. Okay. Size of fan must be larger. Specific heat capacity must be higher atau high. Higher pun boleh. Boiling point also must be high. Freezing point must be lower. Lower maksudnya kalau winter tu temperature dia drop -4, maksudnya freezing point cooling liquid maybe -50 ke gitu. Ataupun -100. Okay, kita ada 5 points ni. 1, 2, 3, 4, 5. If you have more, you can write. You can write more if you want. Okay, because this one is a suggestion of modification. Okay, write more if you want. Okay, now we try to give explanation for all the suggestions. Okay, number of fin blades for the radiator. Number of fin blades more. Fin blades untuk yang cooling, cooling dia. So mesti more so that it will release more heat energy. Okay. Size of fan must be larger. More air. Okay, specific heat capacity higher means absorb large amount of heat. Okay, able to absorb large amount of heat. Boiling point must be high so that not easily change to steam atau not easily boil. Okay, freezing point not freeze easily or change to solid. Okay, so you have 5 points here. Okay, 5 points. So suggestion, one pair. Suggestion cannot be repeated, but reason can be repeated. Explanation can be repeated, and marks. Okay. Okay, so for essay part, paper 2 or paper 2 section B or C. Okay. You must try to answer. Okay, try to use the concept related correctly and try to answer using table form. Easy. Okay, examiner also easy to see your answer. Even yourself also can easily check again. When you have done, you want to check again your answer, you can just check easily. Okay, because the table can be, we can just go through it again easily, compared to one lengthy essay, for you all to write. Okay. Section B and section C, normally you just go and look at concept, principle, law, okay, bahagian application. Okay, for section B especially, there's a calculation problem. Calculation. Okay. Kalau sebut konsep, apa maksud konsep? Concept of resultant force, forces in equilibrium, thermal equilibrium, itu konsep. Okay, force on current carrying conductor, electromagnetic induction. So we call it concept. Principle like Hooke's law, Pascal principle, Archimedes principle, Bernoulli's principle. Okay, Lenz law, Faraday law, itu semua soalan-soalan yang boleh masuk dalam essay part. Okay, application pun banyak. Kalau setiap topik form 4, form 5 tu boleh lihat apa application. Okay, contoh kalau macam tajuk wave tu, apa application. Jadi dia ada 4 phenomenon. Contohnya, nak to build resort near the beach. Okay, what concept related? Refraction, diffraction, interference. Okay, itu application. Okay, kena tahulah. Okay, lagi macam application for electrical appliances, something like iron, okay, something like hair dryer, okay, heating element in the kettle. So you must understand the concept. Normally, many misconception, especially I always, okay, many time already, the difference between heating element and also the like transmission wire ataupun connecting wire lah. Ni dua benda ni. Okay. Heating element you boleh nampak dalam alat seperti kettle, iron, okay, bulb, filament bulb, filament bulb. Ini heating element. Okay. Kalau connecting wire, yang transmission wire, connecting wire, itu semua. Okay, jadi different properties, two different characteristic. Heating element, you kena faham dia punya useful energy ialah heat. Apa useful energy dia? Heat. Okay, ini apa dia ni? Useful energy dia electrical energy lah kan? Transmitted. Okay, current transmitted. For example, untuk kettle. Okay, dalam dia ada heating element. Okay, to produce more heat, so that can boil water, can use to iron your clothes, filament bulb, so that it will glow and produce bright light. So all these require higher resistance, also higher resistivity. For transmission wire, connecting wire, we don't want heat energy, we tak mahu heat. Ini akan menyebabkan efficiency become lower. Useful energy ialah maybe electrical energy ataupun light energy and other energy. Okay, so this one we need lower resistance. Resistivity also lower. Nampak beza dia? Don't get confused ni, dua benda ni. Banyak kali nampak. Okay, salah pilih, salah buat suggestion dan sebagainya. Okay, so I think that's all my session tonight. If you have any question, you can just write in chat. Okay. So actually for the section B and section C, just like frame, dia ada macam satu frame untuk you all answer. The question is always like that. Okay, you boleh nampak dia punya pattern of questions. So means if you understand the technique to answer, I think shouldn't be a problem. The problem is that you don't understand the concept. You don't understand the principle. Make sure you understand then only you can answer. If cannot, how to answer, isn't it? Okay, so make sure you know the technique how to answer. Okay. Okay, you can watch again this video. Okay, if you miss some of the parts, you can watch again. So I think for tonight, I have done for the whole set of model. My first video is about section A, and this is the second video, section B and C. So I think good luck for you all. Okay, those who will sit for trial exam. Okay, thank you for joining me tonight. Bye.